Hello grade 10. So now we're going to be doing lesson 3.9, which is called solving quadratic relations. So we're taking what we learned from factoring and we're applying it to word problems to learn how to solve them. So there's a handout on Teams that you should print and then fill in while you watch this video. It's called lesson 3.9, solving quadratic relations. So at the top of the handout in the key ideas box, you'll see a sentence. It says, math involves working with truth statements, where an equal sign declares that the left side of an equation is equal to the right side of the equation. For example, 2x plus 1 equals 3x minus 2. In this example, there's only one value of x that would allow this to be a truth statement. To solve this equation then means to find the unknown value for x. So let's do that. In order to do that, we would be moving everything over to one side, all the x's over to one side to solve for x. So we'll start by adding 2 to both sides. So when I do that, I have 2x plus 1 plus 2, which is 3. And 3x minus 2 plus 2 is just 3x. Then I'm going to subtract 2x from both sides to get all the x's over to the right side. And then I have 3 equals 3x minus 2x is 1x. So therefore, x equals 3. So this equation is only true when x equals 3, so the solution is 3. The second point in that box says, to solve a quadratic relation means to find the unknown value which makes an equation true. This means you must be given the value of the other coordinate. So for example, they give you the y value, but you don't know the x value. In the example, x squared minus x equals 6, the given value is y equals 6, and the unknown value x can be found by, okay, so let's just recap what that said. X squared minus x equals 6. In this situation, the value that they gave you was 6. So that's y equals 6. That's what goes in the first blank. And the unknown value is x. That's what goes in the second blank. So there's two ways now we can solve for x. First, we could graph it, or we could do it algebraically. I'm going to show you both ways, and then we're going to talk about which one's easier. So first, through graphing. So if I have that equation, x squared minus x equals 6, this would have originally come from the equation x squared minus x equals y, right? That's on the line x squared minus x equals y. So first I'm going to factor this. I'm going to factor the x's. So I'm just going to write it the other way, which we're more familiar with, which is y equals x squared minus x. And then I'm going to factor the right side. So what can I take out of each term? Well, I could take out an x. So y equals x. X squared divided by x is x. And negative x divided by x is negative 1. Now I have two sections to my equation. So in order to find the zeros, I would set each section equal to 0. So x equals 0 and x minus 1 equals 0. So the first 0 is 0, and the second one I would add 1 to both sides, so x equals 1. So those are my zeros, are 0 and 1. Then in order to get a little more information so I can graph this more accurately, I would find the axis of symmetry and then plug that into the equation to find the vertex. So the axis of symmetry is halfway between the zeros. So I would add them and divide by 2, find the average. 0 plus 1 divided by 2 would be 1/2, which we could call 0.5. Plug that back into this equation here. So y equals 0.5 squared minus 0.5. 0.5 squared is 0.25, minus 0.5 is negative 0.25. So my vertex is 0.5, comma, negative 0.25. Now, using these key features, the vertex and the zeros, I'm going to graph this, and then I'll check where does this, on this line, where does y equal 6, and those will be the solutions for x. I'm just going to get some graph paper here. So I'll label this 1, 2, 3, 4. And I need to go up to 6 on the y-axis. All right, now I'm going to plot the information I know. So I know the zeros are at 0 and 1, and the vertex is at 0.5, negative 0.25, right there. And I'm going to connect those with a curve, and then I'm just going to continue that curve up. So of course it's not going to be perfectly accurate because I don't know exactly where this line is going to go. But now I need to check where on my line does y equal 6. So it's going to happen in two places. About here, which looks like 2.5. So x equals 2.5. And right about here, which is x equals negative 2. All right, so that's one way to find the two solutions. But now I don't know if they're exactly right or not because I don't know that I've drawn my graph accurately. So let's look at the other way to solve, which is using algebra. So if I have x squared minus x equals 6, I can solve for x by moving everything to one side so that my whole equation equals 0, and then I'll factor. So I'll just write that down so that you know what I mean. Solve for x by moving everything to one side and then factoring. All right. So x squared minus x equals 6. In order to move everything to one side, I'm going to subtract 6 from both sides because that's the least things I'm moving around. So now I have x squared minus x minus 6 equals 0. Now I can factor this, x squared minus x minus 6. This is a trinomial with an a value of 1. So I'll need two numbers that multiply to negative 6 and add to negative 1. So numbers that multiply to negative 6 would be negative 3 and 2, negative 2 and 3, 1 and 6, 6 and 1. In this situation, to add to negative 1, it would be negative 3 and 2. So my two brackets would be x minus 3, x plus 2 equals 0. Now since it equals 0 and I need to solve for x, that means I need to find the two solutions for x that would make this equation true. So that means each bracket gets set to 0. So x minus 3 equals 0 and x plus 2 equals 0. Add 3 to both sides on this one. Now I have x equals 3. Subtract 2 from both sides on this one. Now I have x equals negative 2. And those are the two solutions for x. So comparing that to my graph, on my graph I got 2.5 and negative 2. And here I got 3 and negative 2. And this algebra is more accurate than drawing it by hand. So underneath that, and still in the box there on your handout, it says, the easiest way to solve a quadratic relation is to set it to 0. That's the blank. Set it to 0. And find the blank zeros, that's the next blank, which will be the solutions of the quadratic equation. All right, below the box there are some examples. So number 1, x squared plus 3x minus 10 equals 0. So when it says solve in your textbook or find the solution, that means you need to factor this and then tell me the two solutions for x. So find the zeros. So in order to factor this one, I need two numbers that multiply to negative 10 and add to 3. So numbers that multiply to negative 10 could be negative 5 and 2, negative 2 and 5. The combination here that works is negative 2 and 5 because 5 minus 2 is 3. So my brackets will be x plus 5, x minus 2 equals 0. Now that's factored. I need to find the solution. So I need to set each bracket equal to 0. So x plus 5 equals 0, x minus 2 equals 0, so x equals negative 5, and x equals 2. Number 2, negative 2x squared minus 6 equals 7x. Okay, so this one's a little bit different because now we have something on the right side that's not a 0, it's a 7x. So we need to move everything over to one side before we can do anything else so that the whole thing equals 0. So in order to move the 7x over, we need to subtract 7x from both sides. Now when I rewrite this, I'm going to write that negative 7x as my second term because that's how quadratics are set up in standard form. First we have the term with the x squared, then the x, and then the number with no x is last. Make sure you have those in the correct order. Alright, so now I need to factor this. My a value is not 1, so I have to do the fourth type of factoring, which is when I multiply the a and c value together. Negative 2 times negative 6 is 12. I need two numbers that multiply to 12 and add to negative 7. So that would be negative 4 times negative 3. This is when I need to factor by grouping. So I have negative 2x squared minus 4x minus 3x minus 6 equals 0. Break it up into two groups and take out a common factor. So first I can take out a negative 2x. I'll be left with x plus 2. Then I can take out a negative 3, and I'll be left with x plus 2. Now those two brackets are the same, meaning I can combine them. So negative 2x minus 3 bracket x plus 2 equals 0. Now in order to find the solutions, I need to set each bracket equal to 0. So for the first one, I'll add 3 to both sides. Now I have negative 2x equals 3. Divide both sides by negative 2. X equals negative 3 over 2, or negative 1.5. For this one, I'll subtract 2 from both sides. X equals negative 2. All right, for number 3, 3 equals 6x squared minus 7x. So again, this doesn't look like it's in standard form because it's not. So I need to move that 3 over to the other side so that it is in standard form. So I'll subtract 3 from both sides. Now I have 0 equals 6x squared minus 7x minus 3. And now I need to factor. So 6 times negative 3 is negative 18. Two numbers that multiply to negative 18 and add to negative 7 would be negative 9 and 2. So now I have 0 equals 6x squared minus 9x plus 2x minus 3. Factor by grouping. For the first group, I could take out a 3x. I'll be left with 2x minus 3. The second group, I can't take anything out, so I take out a 1, 2x minus 3. My two final brackets are 3x plus 1 and 2x minus 3. I need to solve for x, so set each bracket equal to 0. 3x plus 1 equals 0. Subtract 1 from both sides. 3x equals negative 1. Divide both sides by 3. X equals negative 1/3. And 2x minus 3 equals 0. Add 3 to both sides. 2x equals 3. Divide both sides by 2. X equals 3 over 2, which equals 1.5. All right, onto the back of the handout. Number 4. 17x plus 5x squared equals negative 6. All right, so again, I need to get this into standard form. I'll add 6 to both sides. Now I have 17x plus 5x squared plus 6 equals 0. Now the next problem is that this is not in the correct order. So these two terms have been switched around, We're going to switch them back so that it's in standard form, so we can factor it more easily. So 5x squared plus 17x plus 6 equals 0. Now, in order to factor this, I need to multiply 5 and 6, which is 30. So I need two numbers that multiply to 30 and add to 17. So that would be 15 and 2. 5x squared plus 15x plus 2x plus 6 equals 0. Factor by grouping. So this first group here, I could take out a 5x, and I'll be left with x plus 3. The second group, I can take out a 2, and I'll be left with x plus 3. My final factors are 5x plus 2 times x plus 3 equals 0. In order to find the solutions, I'll set each bracket equal to 0. 5x plus 2 equals 0. Subtract 2 from both sides. 5x equals negative 2. Divide both sides by 5. X equals negative 2 over 5. And x plus 3 equals 0. Subtract 3 from both sides. X equals negative 3. All right, number 5. Y equals x squared minus x minus 30, where y equals negative 24. Okay, so this one's a little bit different because we have an equation in standard form, and now they're giving us a value for y. So we would take that negative 24, put it in the place of y, and then in order to factor this and solve, before we factor, we have to move this negative 24 over to the other side so that the whole thing equals 0. So in order to move the 24 to the other side, I would need to add 24 to both sides. So now I have 0 equals x squared minus x minus 6, because negative 30 plus 24 is negative 6. Now I can factor and solve for x. So two numbers that multiply to negative 6 and add to negative 1, that would be negative 3 times 2. So my solutions would be 3 and negative 2 if I set each bracket equal to 0. All right, number 6 is a word problem. Myrna's fashion store determined that the relation r equals 20 minus 2x times 30 plus 3x models the expected revenue for sweatshirt sales, where r is the revenue in dollars and x is the number of $1 changes to the original price of $10 per shirt. Solve for x when r equals $594. All right, so let's start with the equation. R equals 20 minus 2x times 30 plus 3x. Now we need to solve for x when r equals 594. So in my equation, in the place of r, I'm going to write 594 equals 20 minus 2x, 30 plus 3x. So this is already factored, but it's not factored to include the 594. So what we need to do is we need to unfactor this, which would be expanding like this, multiply, 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 multiply. Then we need to get the 594 over to this side so that the whole thing equals 0, and then we need to refactor to solve for x. All right, so we're going to leave the 594 over there for now. And then we're going to expand these two brackets. So 20 times 30 is 600. 20 times 3x is 60x. Negative 2x times 30 is negative 60x. And negative 2x times 3x is negative 6x squared. Now I'm going to subtract 594 from both sides so that the whole thing equals 0. So I have 0 equals 600 minus 594 is 6. 6 plus 60x minus 60x is 0, so that's gone. And then I have a negative 6x squared at the end. So 60 plus negative 6x squared, or 60 minus 6x squared. Now I can factor the right side, and then I will be able to find my two solutions for x. So first I'm going to rearrange it so that it's in standard form. So negative 6x squared plus 6. There's no middle term because it was 0 here. And the first thing I do in factoring is I look for a greatest common factor. So is there a number I could divide from both of these terms? Well, yes, I could take a negative 6 out. So negative 6x squared minus 1. Now, this is not factored yet because I still have a squared there. So in order to factor this more, this is a special situation where this is actually a difference of squares, because I could take the square root of x squared, which would be x, put 1 in each bracket, and then I could take the square root of 1, which would be 1, and then add 1 and subtract 1. So my completely factored equation is 0 equals negative 6 times x plus 1 times x minus 1. Now I'm going to solve for x by setting each bracket equal to 0. I can ignore that negative 6. So x plus 1 equals 0, and x minus 1 equals 0. Subtract 1 from both sides, x equals negative 1. Add 1 to both sides, x equals 1. So the question asks, solve for x when the revenue is $594. So x is either negative 1 or positive 1. So that means in order for them to have a revenue of $594, they either need to decrease the price by $1 or increase the price by $1. So change the price from $10 down to $9, or from $10 up to $11, and then the revenue would be $594. All right, the last question, number 7. Nancy walks 15 meters diagonally across a rectangular field. She then returns to her starting point by walking along the outside edge of the field. The total distance she walks is 36 meters. What are the dimensions of the field? All right, so here's our field. Nancy walks diagonally, that's 15 meters. And then when she gets there, she returns to where she started by walking along the outside edge. So she goes this way, and then this way to get back to where she began. So I'm going to label the two sides that she walked as x and y, and then we know the diagonal was 15. We know her total distance was 36 meters, so I could make an equation out of that. 15 plus x plus y, so 15, x and y, that all together equaled 36 meters. I can simplify that equation by subtracting 15 from both sides. Now I have x plus y equals 21. And then I can get y by itself on one side by doing y equals 21 minus x, or rearranging to be negative x plus 21, and now it looks more like it's in standard form. Okay, so that's one part of this question. The next part is that I can use the Pythagorean theorem to help me solve for x and y, because I know that this is a right triangle because the field is a rectangle, and this 15 meters would be the hypotenuse because that's the diagonal opposite the right angle. So I could do x squared plus y squared equals 15 squared to find the, using the Pythagorean theorem. So since I know that y equals negative x plus 21, I can use substitution, call these equations 1 and 2, put equation 1 into equation 2, and then I'll be able to solve for x and y. So my first equation was x squared plus y squared equals 15 squared. I know that y equals negative x plus 21. So in the place of y in the Pythagorean theorem, I can put negative x plus 21. So now I have x squared plus negative x plus 21 squared equals 15 squared. Now I can expand this out, simplify, and then once it's all equal to 0, I can factor and I'll be able to solve for x. So I'll have x squared plus negative x plus 21 squared. I'm just going to rewrite those as two separate brackets. equals 15 squared is 225. Now I need to expand out these two brackets. So I have x squared plus negative x times negative x would be positive x squared, because a negative times a negative is a positive. Negative x times 21 is negative 21x. 21 times negative x is negative 21x. 21 times 21 is 441. And that all equals 225. Now I'm going to simplify the left side and subtract 225 from both sides so that the whole thing equals 0. So now I have x squared plus x squared is 2x squared. Negative 21x minus 21x is negative 42x. And then 441 minus 225 is 216. Now I need to factor this so that I can solve for x. So I have 2x squared minus 42x plus 216 equals 0. So the first thing I do when I'm factoring is I always check for a common factor. In this situation, I could take out a 2. So I have x squared minus 21x plus 108 equals 0. And now I just need to factor the bracket. So I need two numbers that multiply to 108 and add to negative 21. So to multiply to 108, I could do negative 12 times negative 9, which is what I'll do. So I have that 2 in front, then I have x minus 12, x minus 9 equals 0. So my two solutions for x, set those each equal to 0, x equals 12 or x equals 9. So on my diagram here, x could either be 12 or x could be 9. Now, my first equation here, y equals negative x plus 21, I'm going to plug that back in, these two options back in, to see what the two options for y would be. So y equals negative x plus 21, y equals negative 12 plus 21, or y equals negative 9 plus 21. So in the first case, y would equal 9, and in the second case, y would equal 12. So my dimensions are either 12 by 9 or 9 by 12. Either one will work for this situation. All right, so there's some homework questions that are posted on Teams that you need to do and then hand in as well. So let me know if you have any questions that need to be done before our next class on Monday. All right, have a good day.